Yeah, so this was the last class. This is the completed circuit. So when you had press, but I said it was supposed to be I. Press I on the keyboard. It's supposed to go to 0 to 1. So when it is the 5 volts, or when the input is a 1, it does that. And when the input is a 0, press I on the keyboard and it goes to 0, and it's going to go. Count in the opposite direction. So that was the circuit from the last class. So one of the reasons why we're going through this before, well, the main reason why we're going through this before PLC is because we're hoping for some amount of easing of the restriction, but I don't see that happening anytime soon. So anyhow, so the other thing about it is that a circuit like this is relatively cheap. All right, 2 flip-flop, a NAND gate and an OR gate. Well, we could convert this to one chip by just converting the OR, building OR using a NAND gate. So there's all of that. So it would be one chip and another chip. So two chips and we'd be good to go. All right. So I want to go from the idea that we had last time, because we were just talking about counter circuits. But now we want to use the same principles that we had to design some other circuits. So here's a problem that I want us to look at today. Took it from out of the PLC book, but we want to design a control circuit to run this operation. When you press start, the sensor for the box, the conveyor belt motor starts to run. When the box sensor pick it up, it stop. Other motor start. When I put in 5, whatever the product is, drop in, then we would start back over, move to the next box, and so forth. So we want to design a circuit for that. I want to just go through the principles and for designing that kind of circuit. I want to do this example today and then do 2 more in the coming weeks. By the way, everybody hearing me?
Yes, sir.
Oh, sometimes.
Yes, sir. Sir, are you recording this session?
No.
I'm recording it.
All right. Good. So this is, we want to look at this circuit. All right. So that is what we want to talk about designing. So let me go run out today. Using a small board today, hopefully. So if you can just pin the next Darren Fraser. So just the whiteboard that is there. So let me just do a little map up. So all right. So we have the thing that we want to design. So the first thing that we are going to have to identify in there are what are my inputs. And my inputs are the sensors and switches. And what are my outputs?
Sir,
And yes, I don't hear you.
sir, can I have permission to record, please?
Yeah, man. You know, when you download some software and they ask for permission to do something and you see the little box over the side, the little box on the left hand side at the bottom of the request. Anybody ever recall seeing that?
Yeah, man.
Wait, say,
Box.
the little box at the whenever you don't know something and there's a little box.
It's a custom.
No, well, no, there's the box where I said, don't ask me that again. Just do
Oh.
it. All right. So let me put up back the question. So we want to get inputs, outputs. We're going to talk about states after that. So what are the inputs and what are the outputs? So we're going to go back to the question. All right. So the inputs are any switches or sensors that we have to detect anything. And the output is any motor, light, anything that we have to turn on, any actuator, any valve that we have to open or close. Those are outputs. Anything that when you put current to it, it turn on or it do something when current go great. And when it do something else when current is not going to. So anything that you have to actuate, turn on or off, that is an output. Anything that you have to switch on, any switch that will switch on or detect a sensor or a switch, that is an input. And then we talk about the states after that. So looking at this diagram, you can tell me what you consider to be your inputs.
So, I think you need to grant permission to record the video in Zoom.
Somebody can tell him the answer, please.
I don't know. I don't know either.
Sir, what me think I can do is let anybody who I go record, make them be the host, but you can still share your screen while they are the host. Probably, I think only the host can record. If me not lie, I'm not sure.
No. Conroy never recorded last time.
Yeah, they record with external applications too.
Yeah, record with that?
External, no, Zoom we use to record it. We use something else.
Oh.
But they are record still. They are recording.
Oh, okay.
All right.
So the sensor for the box and sensor for the Apple are the input.
All right. So those are two inputs. I'm going to write them down. Sensor, box sensor, Apple sensor. Any other inputs?
So the start and stop.
Start and stop. All right. Just realize I don't have. Give me 1 second. I'll get something to wipe off the board. All right. So write down that. So our inputs is a box sensor, Apple sensor, start and stop. All right. We can identify what our outputs are. Anything we're returning on.
Yeah.
They? Say it again.
The conveyor
Which
and the motor.
the motor. So the conveyor. I'm going to put motor B for box and motor A for Apple. All right. So those are our so the inputs are our box sensor, Apple sensor, start and stop. And the outputs are our motor A and B. So after we have identified the inputs and the outputs, the next thing that we have to identify are what we call the states of the system. So the states of the system would be what, well, let me make it simple by just saying what states our output would be in. So motor A can be on, motor B can be on, and so forth. So I'm going to identify the 4 possible states that the system can be in, and using 2 motors. Are you can, if I'm making any sense, you tell me what are the states that the system can be in terms of the output, the motors that we have here.
On and off, sir.
All right. So let me write down. I'm going to put 0, 0 to set both motors off. 0, 1 to say that is A. I'm going to put this A and B. So both motors off, A off, B on. The next state that it could be in is A on and B off. And final state that the system could be in is both motors are on. Now, if we study back the diagram, are any of these states redundant?
Sir, 1 1, sir.
Huh?
Sir, 1 1.
1 1. Why 1 1 redundant?
Sir, because when the Apple are drop, sir, you know the rotor fair move.
Right. So
And likewise with 0 0, sir.
0 0 I agree with you with 1-1. The two motors cannot be running at the same time. But 0-0 can be a legitimate thing. When you turn off the thing when you're going home at night, then both motors both motors can be not running. You agree with me?
Yes, sir.
All right. So now, so let me go back over here now. So the states of the system are these. And more often than not, if we can put the system states in a pattern like this, like we said, this one here we're not going to use, but we still have it there as a possible state. So now, in this particular case, it's not always the case, but in this particular case, we are going to let the states coincide.
Somebody want to let in.
Okay. Yeah, what I was saying, in this particular case, we are going to let the states of the A and B, states A and B coincide with the outputs, which are the two motors in this case. But it is not always that is going to be the case. But for now, for this problem, because it is not a massive circuit that sorry, when I say massive circuit, you have multiple outputs. Then you're not going to, you normally let your states coincide with what you want your outputs to be. But we're going to look at another problem where we're not going to do that. We're going to have states, or we're going to have outputs that are different from the state. But for most of the problems that you're going to do, it is easy to just say, let the state coincide with what I want my outputs to be. So now we're going to turn our attention a little bit to our inputs. So well, we start and we have a stop. For the purposes of this exercise, I'm going to cross off the start off of it. May not understand what I'm saying now, but the start is just an enable to each state. So let me just, so what you normally would do when you design, you put your start switch and your sensor. So when the start is 1, it just enable, we throw an AND gate. So when you start, when your sensor goes high, then the output of the sensor is enabled. So your start just allows the sensor to be enabled. And in the next case, we are going to put, so we're going to leave out the start out of it, out of the discussion. So what is normally done is that we give each of our inputs or I should say one other thing. The Apple sensor. The Apple sensor that we're going to have is the, if you remember the problem, let me go back to the problem. If you read down at the base of the thing, it says, it's going to count 5 apples, and then it's going to, after it counts 5 apples, then it is going to state that it detects the 5 apples. So the sensor that we're talking about in this, where we say apple sensor, is not the sensor to detect the apples, as is in the diagram. It's a sensor to detect when you have 5 apples. So basically, what the 5 apples is going to be, if we're designing the circle, we'll design a counter circle for the counter circuit for the 5 apples. And then when the 5 apples pass, 1, 2, 3, 4, 5, it triggers and say, all right, I finish counting. So we just have a counter circuit that does that. counts the 5 apples, and then when it finish, it triggers. I say I'll finish counting the 5. So the sensor, apple sensor that we have here, we're talking about, is not to sense the apples, but to sense when you count 5 apples. So now, so back to what I was saying here now. One second. All right. So now, the usual thing, I said that I'm crossing out the start, and the apple sensor is when it detects 5 apples. We could do the same thing with the stop, but for the purposes of this exercise, to make it a little bit more, I don't know what you want to call it, interesting. We're going to give each of these inputs here a binary value. So there's 3 inputs we have, so we can give it one. We're going to call it stop 0, 0. We're going to call the apple sensor 0, 1. And we're going to call the box sensor 1, 0. All right. So we line up our inputs, we line up our outputs, we line up our states. And we are saying that we're going to give this line up the states of the system. We just look at the output and determine each of the states. So we said we have the conveyor, apple conveyor, which we call the motor A, the box conveyor, which we call the motor B. And we are saying that they can be in different states, both off, motor A off, motor B on, motor B A on, motor B off, or both of them on. And we have determined that both of them on is not something that we're going to use. Both of them on is not something we're going to use. So we draw a little line through it, we just make a note of it. And we note our inputs are the switches are the whatever you turn on or off any sensor or any switch. So we have 3 switches, and I was explaining that I'm leaving out the start because the start usually is connected via an AND gate to all of the sensors. The start switch is just an enabler. So I'm going to leave it out for the time being. If when you are doing your design, if you want to put in a start switch, that's fine. As a part of your input. All right. So I'm going to be labeling my stopper 0, 0, my apple sensor 0, 1, and my box sensors 1, 0. And there's no 1, 1. Now, from that, we can go straight to the table. By the way, anybody has a copy of the same JK table that we are going to be using that? So put that somewhere near you. I don't have it. Can't bother look it up right here now. All right. So, any questions up to there? Remember, so we can't look at your face to understand, to know if you don't understand anything, you know. So, normally I would look in your face. If anybody mouth open, you say, okay, then I understand a word that we say, and then I would go back over. But,
Good so far.
huh?
Good so far.
All right. So, all right. So, I'm going to write this down.
Sir,
Yes.
How will I know where to make the box sensor stop, sir? We call it the apples.
Where to make the box sensor stop?
Yes, sir. Would you like give it a time?
No, but we'll go back to the. Usually the sensors that you have, it is located right where you want it to stop. All right. So the sensor would be located at the point that you want the box to stop.
Oh.
Give me a second here. Hello? You have to give me, today's my birthday and all of my relatives them calling me. So
Sir,
it interrupted.
one up on the strong, sir.
Yes.
It's up on it strong, sir.
Yes. So give me a second. Let me explain
Sir,
to them some in
65?
class. Huh? I hear you.
I should have told you from before, sir.
So what?
Say your birthday.
No, I wouldn't tell you at all if they never did that call me. So just give me a second to tell each of them to be in class. Okay? All right. All right. So now, let me go to what we usually have is what is called a state diagram. So let me go to the state diagram. Usually have a circle for each state. So we would put the state in each of them. Now remember we had said that we're not using 1, 1. So 1, 1 is not a state that is going to appear in our discussion. So I don't try it here. And then now, what I'm going to be doing at each state, I'm going to look at each of the sensors and say what is to happen when we're in state. So let's start with, we're in a state where both motors are off. Suppose I press this stop switch. Which state would I go to?
Would move.
It would move. So what I do is draw an arrow going back onto the state. And I put 0, 0 to indicate, the inside the circle is the state, outside the circle is the switch. And then, although we don't need to, but you always put a line and say what the output is. But the output in our case is the same as the state. All right. So the output is the same as the state. So next thing now, if we are in 0, 0, and let us say that we are enabled the box sensor. The 0, 1 is which one again? State 0, 1 is, let me just say this is A and this is B. A is Apple motor. All right. we have to put in the start. Sorry. If we are in 0, 0, if we are in 1, 1, sorry, I'm going to put in the start. Going to complicate up discussion if I don't put it in. So sorry for crossing it out. I'm putting it back in and giving it the number 1, 1. So I put it in back the start and I'm putting in back the binary value 1, 1 for the start. So that it won't complicate up our discussion. I will point out that there are several approaches to the input circuit that we're going to talk about, but for the sake of the discussion, we're going to use 1, 1 for the start. So 0, 0, if you stop, you stay in that state. So what about if you had 1, 1? If you press start, what would be the first thing that you'd expect to happen if I press the start motor? The system is off, you come in and you press the start. What is the first thing that you'd expect to happen?
Yeah, move to the next
Box would
stage.
move. So you turn on the box motor. So therefore, you would go to 1, 1. 1, 1 would carry you to the state 0, 1.
So that is Apple, you know.
Huh?
That is Apple. 0, 1 is Apple.
No, man. That's what I was saying. We label it 0, 1. The 0 is for Apple and B is for box.
Okay.
So the box would have turned on. Right?
Okay.
So 1, 1, 0 would be for the Apple. All right. So now consider the next scenario. And you have two possibilities that you do here now. System is off and the Apple sensor turn on. What would you do? Yeah, it's this state here 0, 0. The system is off and for some reason Apple sensor turn on. What would you do? What would you want to happen?
I want to turn off.
You don't want it to stay in the off state.
Yeah.
Okay.
As in, yeah, so the Apple is on, but the system is on, off.
Off.
Oh, okay, yeah. You want it to stay up.
All right. So you want it to stay off. So that is one scenario. The other scenario that persons do is just use it as a can't happen, which is the same as a don't care. So they don't include it in the diagram. So that's what I was saying Wednesday. So you can either take the approach that I'm going to make it scoop it back onto the system and say that, okay, if it is off and I press the switch, it will stay off. Or I can just ignore it and say it's a can't happen condition. So we just leave it as a can't happen condition.
That seems simple.
Huh?
That seems simple. We just leave it.
Leave it. And if you allow me to go back to the diagram, let me just do a share screen and point out something. You see this that we have here? The circuit that we talked about on Wednesday?
Yeah.
If I turn it on, and in the middle of it, I change. Let me change. No, that is wrong. I changed it at the wrong point. If I change it in the middle of it would have been, you wouldn't see it so quickly, but I changed it when it was 0. It went to 2 and then 3, and then it started going back into the sequence that it's supposed to be going 1, 2, 3, 1, 2, 3, 1, 2, 3. So when the switch was made, it was at a number that was not in the sequence 1, 2, 3. It was at 0, but it went from 0 to 2, and then it went to 4. In other words, it found its way back into the right sequence. So what I was telling you last time was that you can force it to go to a value. You can design it to force it to go to a value, or you can make it find its own way to the value. I don't know if to the new sequence that it's supposed to go to. So what I'm in essence, what I'm trying to say is that if I have it as a don't care condition. All right, so we'll go back to this diagram here now. So what I'm saying is that if I loop it in and make it stay, if I put the Apple sensor and say it stays on off. So when I press, if the Apple sensor goes on, turns on, it just stays in 0, 0. Then I'm forcing it to stay where it is. But if I leave it out, it will find its way. The circuit will find out. It may not be as
Quick.
efficient as if I put it in the system. But if I put it in, then the circuit is going to be a little bit more complicated. So I don't know if that makes any sense to anybody. All right. So to simplify our circuit, we're going to leave it out. And the same thing applies to our box sensor. If the system is off and the box sensor for whatever reason goes on, then either you're going to put it, loop it, and say it's going to stay back in the same state, or you just leave it as can't happen. So you don't care. And you leave it out. All right. So next thing now, we're going to go to state. And what I said, these things that we have here, these lines and everything like that, those are outputs. But in our case, the output at the given state is the same as the state. All right, it is easy when you do it like that, but you don't have to. All right. So 0, 1. So 0, 1 says that the box motor is on. So first, go back over here now. And we're going to go back through each of these. So if I press stop, and I'm in state 0, 1, where should I go? If I press stop, I'm in the state where the box motor is running, and whatever happened,
So you're back to 0, 0.
back to 0, 0. All right. If something happens, conveyor head get caught in the conveyor belt, and you have to press stop, then you go back to 0, 0. So what about now? 1, 1. If I'm in the motor is running and somebody come and press, oh, we need to start up and press start. Maybe it is another route. What would you want to happen there? The thing is already running and somebody press start.
You can continue on.
So you can probably stay there.
Continue. So you're going to make it stay in the state. What if it's running and the Apple sensor come on? The box motor is running and the Apple sensor come on. Is that a scenario that is likely?
Well, it's possible in a real life, yes, sir, but we don't consider it now.
All right. So we're going to say that is a can't happen. And what about when the box motor is running and the box sensor come on? What are you? The box sensor means the box reach the right spot. So what is to happen there now?
Repeat that.
Huh?
Go again, sir.
The box motor, this 0, 1. So the box motor is running, so it carry the box to the position, and the box sensor come on to say, yeah, it reached the right position. When the box reach the right position, what do you
Need to turn on the Apple sensor now.
turn? So therefore, we're going to go to the Apple. So this now, 1, 0 is going to carry us to state 1, 0, where the Apple motor come on and the box motor stop. All right, so the third and final state now. You press 0, 0. So without any discussion. If you're in that state and you press 0, 0, then you go back to, you stop everything. So what about if you press 1, 1, which is the start? Apple sensor running and somebody press and the start button is pushed.
It just continue, sir.
All right. So you stay in this state. Apple motor is running and the Apple sensor say we count 5. So we don't count the 5 because no, that is what the Apple sensor is to detect. So we finish count the 5. So that Apple sensor now say finish count the 5. What are you going to do?
So go back to the box sensor.
So you go back to the box. And the final thing, well, the Apple sensor on here, the box sensor come on. Well, that is again, we're going to ignore that. So this thing here is called the state diagram. So this thing that we have here is called the state diagram. Now, from the state diagram, we're going to make up our state table. So it's going to be the same thing that we did from there, from here, this diagram here. We're going to make up a state table. So we're going to have I'm going to call it I1, I2, A, B, the next state, which is going to be A star, B star. Then we're going to have JA, KA, JB, KB. And so for these states, now we're going to put in our 16.
Sir, a good thing we are recording because we just answer the phone and now I'm totally lost.
Okay,
Totally.
not a problem. So this state table here, you did all right up to here?
So I'm drop out right when we go to 1, 0. So
Right when we go to 1, 0. So 1, 0 mean the Apple motor is on it and the box motor is off. So we were saying all the different conditions. If when the Apple motor is on, let's say your head gets stuck in the machine, then we have to turn it off. So the 0, 0, which is the off ID, carries it back to the state where both motors are off. You agree with that?
yes.
All right. So the next one was if we press the start switch while the conveyor is running, then what your classmate said, and I agree with, is that it just should continue running.
Yeah.
And then 0, 1 was that if the Apple sensor goes off, then what is to happen is that it's going to start back the box motor, get another box, start another box.
Okay, all right, yeah.
And then we ignored the Apple sensor. because the Apple sensor. We didn't put that in there because the Apple sensor. Sorry, which one of them? The box sensor can't go off while the thing is running.
Yeah.
These are those states that we ignore. So from this, we're going to draw back the same table. So these are the I1 and I2 would be my input. The A and B would be for the motor, present value of the motor, and where the motor would be going next depending on the input. And then we'd have the J and the K flip-flops. So we're in the process of making up the table.
All right, sir. Thanks.
So we're going to leave it as an exercise for you to finish next class. But let us do the first one. If I'm in zeros, if the state is 0, 0, which is this, and I press 0, 0. So input is 0, 0, the state is 0, 0. What is the next state based on the diagram? Input is 0, 0. The state is 0, 0. What is the next state?
Still 0, 0.
State 0, 0. So I'll put 0, 0. Input is 0, 0, and I'm in state 0, 1. I'm in state 0, 1, and the input is 0, 0. The next state is going to be 0, 0. And so forth and so on. If the input is 0, 0, and my next state is 1, 0, I'm 1, 0, and the input is 0, 0, I go back to 0, 0. So this would be 0, 0 as my next state. And my input is 0, 0, and my state is 1, 1. I ignore the state 1, 1, so I'm going to put a don't care. Everybody see where we're going with this?
Yeah.
All right. Input is 0, 1. Present state is 0, 0. Input is 0, 1. Remember now, we don't have a 0, 1. So to the two inputs we have here, 1, 1, 0, 0. So if my present state is 0, 0, and my input is 0, 1, I don't have that on my diagram, so I'm going to put a don't care. Input is 0, 1, and my present state is 0, 1.
Okay, okay.
My present state is 0, 1. Let me see if I have my input 0, 1. No, I don't. So I'm going to put don't care, right? Input is 0, 1. Present state is 1, 0. Input is 0, 1. This is present state is 1, 0. Input 0, 1 carries me back to 0, 1. And so forth. So here's what I'm going to ask you to do as an exercise and carry come next class. Is fill out this table. Because what we're going to do is fill out the table, fill in the J and K values, and then from the J and K values, then we're going to draw the circuit to control the plan. So that is where we're going to fill out the table and then draw the circuit next class. And then next class we'll look at another example. All right? So I did say we're meeting for 1 hour.
Sir, when I reach on campus, you buy a 2 beer, yeah?
All right, cool. All right, so we stop in there. And then we take it up next class. So as an exercise, finish the table, finish the JK. I am going to do it as well. And we compare notes. Okay?
Sir, can I see this again?
Today?
The stereo diagram.
All right, sir.
All right. So the exercise is to finish this table. Now when we finish this table, we're going to simplify it and draw a circuit. So everybody come with them circuit next week. And so next week we give you the assignment. So that is your 10%. All right. As a matter of fact, when I try to post up the assignment, not today, I'm going to buy myself something.
Bless up yourself, sir.
Yeah. I'll post it up tomorrow, Sunday. All right. So Wednesday when we come, we discuss again. Okay?
Yes, sir.
All right.
Enjoy your day, sir.
Yes, thank you. So all right. All right then. So